Okay, next time you're outside, just look up. We see it every single day, right? The sky is blue. But have you ever really stopped and wondered, why?
I mean, it just feels like one of those "that's just how it is" things. But it's actually a pretty amazing question.
Yeah.
Who or what is painting the sky that color?
And you know, the more you poke at it, the weirder this whole thing gets. Think about it. The sun, our light source, it's this brilliant white-yellow ball. The clouds, they're white. And space, right beyond our atmosphere, it's totally pitch black. So where is all this blue coming from?
And here's the kicker, the really strange part. Nothing up there is actually blue. The air itself, invisible. So if the light source isn't blue and the air isn't blue, what on earth is going on?
Well, we are going to break down this beautiful puzzle right now. This is a quick STEM curiosity from Byte to TeraByte.
To get our heads around this, we're not going to start with a bunch of complex physics. Nope, we're going to start with a simple story. Let's call it the playground analogy. Just picture this. You're standing on a playground. A friend of yours grabs a whole handful of different kinds of balls. Some are big and heavy, others are small and light, and just throws them all at once across the ground. Now just watch what happens. The big, heavy balls, they just plow straight ahead, right? They roll in a straight line. But what about the small, light ones? They go completely wild, bouncing off shoes, bags, bench legs. They scatter in every single direction.
And that right there, that's the one rule you need to remember. Small things scatter more. Just lock that idea in your head because it is the absolute key to this whole mystery.
Okay, so let's take that picture of scattering balls on the playground and connect it directly to the physics of sunlight. So, first off, sunlight might look white to us, but it's actually a whole rainbow of colors all traveling together. Now, to get down to us on the ground, that light has to punch through our atmosphere, which isn't empty. It's full of tiny, invisible particles. And when light meets those particles, well, that's when the show really begins.
And here it is, the big connection. The blue part of that sunlight acts just like those small, light playground balls. Because it has a short wavelength, it gets scattered super easily by all those tiny particles floating around in the air. So instead of making a straight shot from the sun to your eyes, that blue light just gets knocked around all over the place. It bounces sideways, upwards, downwards, just spreading out and filling the entire sky. Okay, and this is the big aha moment. When you look up, you aren't seeing some big blue thing. No, what you're actually seeing is light that's been bounced around billions and billions of times. You're seeing scattered blue light coming at you from literally every direction. So we've pretty much cracked the code for the blue sky. But what's really, truly amazing is that this one simple idea, scattering, it doesn't just explain sunny afternoons. It actually explains two completely different skies. But first, let's just let this sink in again, because it's a mind-blowing idea. The sky has no color of its own. The air above you is just acting like a giant light filter, taking in all the sunlight and just flinging the blue part everywhere. Now watch how this same exact rule creates a sunset. It's so cool! So during the day, the sun's high up, right? The light takes a short trip through the air, so you see all that scattered blue. But at sunset, the sun is way over on the horizon, so its light has to travel through way more air to reach your eyes. And on that super long trip, pretty much all the blue light gets scattered away from you. So what's left over? You got it, the reds and the oranges. It's just fantastic, isn't it? One simple rule from physics gives us two totally different but equally beautiful results. A nice, calm blue sky and a fiery orange sunset.
It really is a perfect example of the laws of physics just quietly doing their thing in the background, shaping the incredible, everyday beauty that we so often just take for granted.
So the next time you step outside and look up, remember what you're really seeing. It's not just a color. It's sunlight on this incredible, playful journey, bouncing all over the place before it finally gets to you. Our goal here is to help you understand the idea, not just memorize a formula. This is Byte to TeraByte.